welcome back to the series. So in this video lecture we'll be learning to implement this trie data structure, which is the prefix tree. So this problem, implement trie, contains the implementation of the trie data structure. So it contains we have to implement a class trie which contains a constructor trie which will initialize an object of this type trie. Then we'll have a function insert which takes word as an argument. It inserts this word into the trie. Then we have a function search. It returns a boolean variable, true or false, depending upon whether this word exists in the trie or not. And then finally we have this function starts with, which checks if we have a word which starts with this prefix which we have here. If we have such word, then we return true from this function, otherwise we return false. So how we can solve this problem, how we can implement the trie, let's see that. So here we have our dictionary which I want to insert into the trie. So we can imagine that, let's say I start inserting this word trie. So corresponding to this trie, I must have a pointer which points to the next node which contains this R. So to implement this type of functionality, I create an array corresponding to each node of the trie, which can store a pointer to all of these characters which are present in these words. So let's say in these words the range of the characters is from small a to small z, and we have 26 characters in this range. So for every node we create an array. We must have an array of pointers of size 26, where every position, like the first position stands for A, second is for B, third is for C, and so on. Let's say we want to insert T. So I want to insert T. So let's say we have T here. Now inserting T means at this point T points to some other node which contains this R. That's what this means. Now that node also contains a corresponding array to which this T points, and in that array we must have R somewhere, and this R points to next node which contains this Y, and we can traverse from one node to another. So we can start with T, we can move to this node, and then we can move to this node finally. So that's the type of node structure which I want. To do so, I also want to mark that Y is an ending character. So for every character we must know whether it is an ending character or not. Like here in this case, T is not the ending character, R is not the ending character, but Y is the ending character. So after we have stored a pointer corresponding to Y which points to some next node, we must have another variable. Let's call it is_end variable, and this is_end variable must be marked to true. So we use a boolean variable for every node, while here in these cases is_end is marked false. It is marked false for this node as well. Now let's say I also have a word tr in this trie. If we have this word as well, then that means this boolean variable corresponding to this R is marked as true, so that we can simply check whether a given character is the ending character for any word or not. Fine. So let's just see the typical structure. So we'll use struct node, let's call it node, and this node contains two elements. The first is an array of pointers. So an array of struct node pointers, let's call it children, of size 26. This stores pointers to the corresponding nodes and a variable is_end. So this is a boolean variable is_end. So this is the typical node structure which we'll be using for implementing trie. So let's see how they are actually implemented. So let's try to insert try into this trie. Okay, so we have this typical character. So we have this. So since I want to insert this trie try, I will start with T, so I will initialize an object. I will initialize a node corresponding to this tree. So in this node we'll have a array of pointers. So an array of 26 pointers where we'll have T somewhere, and we'll have a boolean variable is and, which is marked as false. Now this is the node corresponding to the first character. Now we move to the second character. Here this T must points to the node corresponding to the character R. So we must have a node corresponding to the character R. So here we again have an array of size 26, and we have R somewhere. Now this R points to another node corresponding to the third character, which is character Y. And here is and is again marked false. Now here we again have a array of size 26, and corresponding to this character Y, we'll again have a pointer which points to some next node. And here this is and variable is marked as true, because this Y, this character Y, marks the end of this word. Fine. So we simply started with the root node. We created another node pointer to which I stored at this location corresponding to the character T, and I moved to this node, and I repeated the process for this character as well until I arrived at the last character, where I simply marked the is and variable to true here, because this is the ending character. So this is how I store a word into the try. So let's say I want to now in the next try I want to insert tr. This is also a word. How would I insert? I will start with this root node. Now this is the root node basically, and I will simply check if T is there or not. So because I want to check for T, I can see that T is present here. T points to the next node. So I move to this next node. Now I check if this next node contains this R or not. We can see that this contains R. That means this node, or the character corresponding to this node, marks the end of this word. And just to insert this word, I simply mark this is and variable to true. I turn it to true. Now I also have tr into the try. Let's say I want to insert t r I e. I want to insert this. So I will start with the very first character, which is T, and I will start from the root. Now this root contains this tree. I can see that it contains this tree. This T points to the next node. I move to the next node. Here in this node, I can see that I also have R. Now this R points to the next node. Now in this node we have, do we have I? No, we do not have I. That means I create another pointer from here, from R, which, so I create another pointer from this point, like here we may have somewhere, we have I somewhere, and this I points to another node, like this. I create another pointer corresponding to the character I. So this pointer points to another node corresponding to this character E. So I is stored here. And here we created a node corresponding to the character E. Now in this node we again have an array of size 26. We again have is and variable. Now here we can see that E is the last word of this. E is the last character of this word. Now again we create a pointer. We create another node to which this pointer placed at position E points, and we mark this node as the ending node. So we mark it as true because E is the ending character. Fine. So in this way a word is inserted in the try. So let's jump to the code implementation part. So this is the try class. So let's create a node here. So here we'll create a node, struct node, or let's call it try node. And here I will have two things. The first is a pointer of type struct try node, children, which will be of size 26, and a boolean variable, let's call it is, and we also declare a root node here. So try node of this type, we create a root node here. Now this root node is accessible in all of these functions and constructors. So here this is a try constructor. So in this constructor we simply initialize a try. So we create a try, new try, and we initialize this try node to this root node which I created here. Fine. In this case, we initialize this root to a new try node. Okay, so we create a try node here of this type and we initialize our root with this new node. Now this root node will simply contain the first characters of the words which we want to insert. So let's we are here to implement the insert functions. Let's implement it. So to insert a word here given, we first create a pointer to the try node. So let's call it p, initialize it with the root, iterate over the word, check if the current character is there or not. If the current character is null, that means it points to none of the node. Then we store this character into the try. So c minus a, we simply call it new try node, because the current character points to the next node of the try, and we move to the next node which we have created. And finally, when we are done with traversing this word, we simply mark the ending variable to be true, because the last character marks the ending of this word which we are trying to insert. Fine. So in this way we insert our word into the try data structure. So let's implement the next functionality, that is search. So let's see how we can search a word into the try. So this is the try which we have builded, and this try contains three words, try, try, trie, and tr. So let's say I want to search for try. I want to search for try. I start with the root node. I check the pointer corresponding to the very first character, which is t here. So here this root must contain a pointer to t. So it do contains a pointer. Now we move to the next node to which it points, which is this one, and here we are expecting a pointer corresponding to r. So we again have a pointer corresponding to r. Now we move to the node to which this pointer is pointing, and here we expect a pointer corresponding to y. Again we have a pointer corresponding to y which points to another node. And we also expect that here the is and variable is marked true, and indeed it is marked true. That means try exists in the try, so we return true from here. That's all we have to do. If this does not marks the end, or probably let's say I want to search for trye like this. Now from the node corresponding to this y, I can see that there is no pointer which points to this character e. We do not have any such pointer, because here we can see that here in this node the pointer corresponding to e will be null. The pointer corresponding to e will be null. That's why for this type of word we return false. Okay, and because here this is and the is and for this is marked as false. Fine, so let's jump to the code implementation part. So here we want to search for this word into the try. So let's create a try node. Let's call it p, initialize it to root. Now iterate over the word. Just check if a particular character on which we are standing do not exist in the try. If it contains a null, that means we return false from here. Otherwise, if it contains a pointer to the next character, we move to that next node. And at the end, we check if this is and is marked true or not. We return that. Like P, oh, not. Fine, so that's all. Let's jump to the next function, which is starts with function. Now this function basically expects us to like implement a functionality whether a given we are given a prefix. Let's say we are given T R I, we are given T R I, and we want to check if there is a word which contains T R I as the prefix. So we want to check for it. Let's see how we can do that. We traverse this word. We start with the very first character, which is T. We go to the root node and we ask whether there is a pointer corresponding to the character T here in the array. And yes, we have it. Now we move to the node to which this pointer points, which is this one. And now we also move to the next character, which is R. Now here we are expecting if we have a pointer corresponding to the character R. Yes, we have. So we move to the next node to which this pointer points. And here finally we are at this node we are expecting if we have a pointer corresponding to the node I, to the character I. Yes, we have a pointer corresponding to the character I here. So we move to the node to which this I points. And finally here I want to check if this is and if the is, and that means we have found all of three characters of this word. That means there must be at least one word which contains this try, which contains this prefix tri. So we return a true from here. Fine. So that's all. Let's just jump to the code implementation part. So this is the starts with function. So let's take a try node. Let's call it P, initialize it with root, iterate over the prefix. So I check if the current character is present in the prefix or not. If it is present, if we have a pointer corresponding to the current character, then that means we simply move to that one. So if we do not have a pointer, so if we have null for any character, then we return false right from there. Otherwise, we move to the pointer to which this character points. And at the end, we return true because we have found the prefix in the given try. Fine, so that's how we implement this functionality. Let's submit it. Okay, compile error. Okay, we have to do it. Okay, children C minus A. Let's run it. Accepted. Let's submit it. Okay, it is accepted. So that's all. Let's just discuss the time complexity for the let's discuss the time complexity for the functionalities which we have implemented here. So let's see for the insert. We can see that for inserting a given word, we are iterating over the word of the try. So let's say the word has a length of k. Then that means the time complexity to insert a word of length k would be big O of k. Okay, and let's see the time complexity for search. So to search a word in the try, we are iterating over the word, and if the word has a length of k, then the time complexity will be of big O of k. Similarly, let's say we want to search if there is a prefix, if there is a word with the given prefix and the prefix has a length of k. Now we are iterating over the prefix, and that's why the time complexity for that would be big O of k. Okay, because Moving from one node to another node is a constant time operation. So the overall time complexity will be big of k, where k is the length of the word which we are passing to search or to insert or to check if there is a word in the trie where this word behaves as a prefix. Fine. So that's all. These are the basic functionalities of a typical trie data structure, although there are a lot of other applications which we'll be discussing in the upcoming videos. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel and stay tuned with me for more videos on the tries. We'll also be solving a lot of problems on the tries. So I hope to see you all in my next video.